Okay, so today we're going to start learning about applications of midpoints, and there are two applications that we're going to focus on. One of them is median, and the other one is called a right bisector. So we're going to start with the definition, and then we're going to look at how we can actually find the equations of these lines. So this is going to use some of your grade 9 knowledge of finding equations of lines. So the first one we're going to look at is median. So the definition of a median is that a median is a line segment that joins the midpoint of one side to the opposite vertex in a triangle. Okay, and as you could probably imagine, there are actually three medians in a triangle. We could have the midpoint of this side right over here to join to vertex A, and we could have the midpoint of this side C joined to vertex C. Okay, and a right bisector is a line that is perpendicular to a side of a triangle and passes through that midpoint right there in a triangle. Okay, so we're going to learn how to come up with the equations of these particular line segments or lines. Okay, so here's our first example, and we're going to learn how to determine the equation of a median. Now, one thing to note, when you try a question like this, it won't actually be all scaffolded like this with all the different parts to do. You just have to know how to find the equation of the median. Okay, so we have a triangle is formed with these three vertices. So obviously one of our first steps just to visualize this idea would be to graph it, and that will just help us to see exactly what we're talking about here. Okay, so here's our triangle. Obviously, you could do this with a ruler, and it would be a little more exact. I'm even going to just actually zoom in on it just so we can get an image. So we are trying to find the median from vertex C. Okay, so just to get a rough idea of what's happening here, and I think I'll do that in red. Okay, we want to find the midpoint of AB, so somewhere around here. And then we want to, that is the median from vertex C right there. Okay, so that's what we're looking to do. So first thing we're going to do here is we are going to draw the median in from vertex C, and we're actually going to then find the midpoint of AB, which let's just call that 1M. Okay, so using the coordinates, we know how to do that. We know that M is going to take, we're going to take the average of the x coordinates of A and B, so 8 plus 2 divided by 2 is 5. And then we're going to take the y coordinates, 2 plus 4 is 6, divided by 2 is 3. So that's actually the coordinates of this point, and you'll see on our diagram we're actually pretty close to 5, 3 there. Okay. Next step is to find the slope of that red median line there. So obviously we can use the slope formula between the points M and C, or we can just look on our picture if we have a graph and we can find the rise over the run. And I think you'll be able to see here that from this point 5, 3, we actually rise up 6 and over 1. Okay, again, you can use the coordinates to figure that out, but you should be able to find out that little m, the slope, is actually 6. Okay, so now we have a point on the line, 5, 3, and we have the slope, which is 6, and we're going to use our grade 9 knowledge to write the partial equation. So the partial equation is y equals 6x plus b. Then, of course, we're going to sub in the point for x and y, so y is 3. We have 6 times 5 for x plus b. So b is going to be 3 minus 30. And so b is negative 27. And therefore, then, the equation for the median is y equals 6x minus 27. Okay, so we're going to practice this idea again without all the individual parts. And one thing you need to know is understand the definition of what a median is. Okay, so for this example, we're going to find a right bisector. You can actually find a right bisector in a triangle, or it can actually just be of a line segment. So we'll go through this idea first with just the line segment PQ. So let's take a minute and just plot PQ. Okay, so first thing we need to do is, of course, find the midpoint of PQ. So just using the coordinates, we can find the midpoint of PQ. We have -4 plus 6 is 2, divided by 2 is just 1. And we have 1 plus 5 is 6, divided by 2 is 3. And it should work out nicely when you have this picture. It's pretty close here. We'll call that our midpoint M. Okay, so again, what's a right bisector? A right bisector is a line that passes through the midpoint of a line segment or side of the triangle and is, of course, perpendicular to PQ. So we're trying to come up with the equation of this red line right here. Okay, and I think it should make sense to you that we obviously have a point on the line. So now we need the slope of this line. And hopefully you remember from grade 9 that these lines are perpendicular, so their slopes are negative reciprocals. Okay, so first thing we need to do then is, of course, find the slope of line PQ. So let's say the slope of PQ. And again, on your picture, you can use rise over run, or you can use the coordinates of the 2 points, and you should be able to find that the slope is 2 over 5. Okay, and this would, of course, mean then that our bisector, our perpendicular slope, would be the negative reciprocal. We're going to flip those numbers. Okay, so just like previously, we now have the slope of our bisector. We have a point because it crosses through the midpoint. And now we're going to go through and find the equation of the line. So the partial equation is y equals -5 over 2x plus b. We're going to sub in our values. So we have 3 equals -5 over 2 times 1 plus b. So b is 3 plus 5 over 2, which is b, which ends up being 11 over 2 for b. And therefore, the equation of the right bisector is y equals -5 over 2x plus 11 over 2. Okay, so hopefully that makes sense to you, and we'll see you tomorrow in class, and you're going to practice these ideas.